Special case of theta 1 equal to theta 2 equal to theta. Did you notice that when I put the value, I am not putting sine theta minus sine theta. I just put the value theta because the minusness is there in the formula. So guys, what is your Ex expression? K lambda by r sine theta plus sine theta. That's 2k lambda by r times sine theta. And guess what? Ey becomes 0. Common sense would have told you anyways. Of course, yes. If the upper half and the lower half are symmetric, isn't the y component of the lower half and upper half are nullifying each other? Absolutely. Perfect. Isn't it? For a symmetric body, again, mark my words, good statement. For a symmetric body of symmetric geometry and symmetric uniform density, for a uniform body of uniform shape, size, and charge density, electric field will always be along the unique axis of symmetry. Very, very important point. For a uniform shape, uniform size, and uniformly distributed charge system, electric field will always be along the unique line of symmetry. Tell me, for this rod, what is the only unique line of symmetry? Perpendicular bisector. Is it positive? Yes, away. Is it negative? Towards. So 2k lambda sine theta by r is the field. For a positive charge, it will be pointing away. Got it? Perfect. Let's take even more special case. Semi-infinite wire. Semi-infinite wire? How can it be a semi and infinite? Well, one of the end is known, the other extends till infinity. That is rightly or wrongly sometimes, but well accepted nomenclature of semi-infinite wire. Okay? So don't argue that. There you go. Did you see the known end ends here, and the dot dot dot, the extended line extends to infinity. So this thing extends to infinity. Okay? In that case, if I map this diagram to my original result, my theta 2 is 0, my theta 1 is 90. All right. So x component is k lambda by r sine 90 plus sine 0, k lambda by r, and the other one is k lambda by r again. Okay. So the two components are k lambda by r, k lambda by r. Sir, I understood that this k lambda by r is pointing away. How do I remember that this k lambda by r will be pointing down or up? Again, entire rod is above this. So all the DEs will keep on pointing down. So the component has to be down. Common sense. Okay. So a semi-infinite wire at the known end r away has a net electric field having two perpendicular components, k lambda by r pointing away, k lambda by r pointing down. Had it been a negative charge, exact opposite. And the net electric field is root 2 times k lambda by r. But I would like you to remember in both the components form, because the resultant you can take anytime you want. Got it? Semi-infinite wire is clear? Perfect. Shall I take one more special case? All right, with your permission, it's infinite wire. How do I know? Look at the dotted line extending both ways. All right? And P point R. Sir, is this P point along the perpendicular bisector of infinite rod? Maybe. But sir, they haven't mentioned it. They don't need to. Every point is a midpoint of infinite wire. So this time, they will not even say midpoint. They will simply say at a point away from an infinite wire, because all points will always be along the perpendicular bisectors of infinite. Every point is a midpoint. Special case? Oh, that's beautiful. Look how the radius vector is deflowering itself to cover the entire infinite wire. Watch. This is how the angles change, right? Watch it again. That means theta 1 is equal to theta 2 is equal to 90 degrees. When I put that, I get sine 90 plus sine 90, 2k lambda by r, and Ey goes to 0. So for a infinite wire, there is only one component of electric field, and the value is 2k lambda by r.